What is the length of the crossbar if the porch swing frame is 60 inches apart? At the end of this lesson, you should be able to prove the conditions for a quadrilateral to be a parallelogram. Prove that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is half of it. John is forming different types of quadrilaterals. What is the difference between the two quadrilaterals? The first is an ordinary quadrilateral without any special properties, but the second one is a parallelogram. It has opposite sides parallel and equal to each other. So, what is the least required condition for a quadrilateral to be a parallelogram? A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. ABCD is a parallelogram and line segments AP and CQ bisect angle A and angle C respectively. How do you prove that AP is parallel to CQ? Here, angle A is equal to angle C since opposite angles of a parallelogram are equal. So, half of angle A is equal to half angle C and angle 1 is equal to angle 2. Now, AB is parallel to DC and CQ is a transversal. So, angle 2 is equal to angle 3. From 1 and 2, we get angle 1 is equal to angle 3. Transversal AB intersects AP and CQ at A and Q, such that angle 1 is equal to angle 3. Corresponding angles are equal. So, AP is parallel to CQ. Given AB is parallel to CD and AB is equal to CD. To prove BC is parallel to AD and ABCD is a parallelogram. Let us draw a diagonal AC. Now, in triangle ABC and triangle CDA, angle DCA is equal to angle BAC. Can you state why these angles are equal? Since AB is parallel to DC and AC is a transversal, angle DCA and angle BAC are alternate angles and hence are equal. AB is equal to CD is given. Side AC is common. So, using SAS criterion of congruence, triangle ABC is congruent to triangle CDA. Can you prove that AD is parallel to BC? Since the triangles are congruent, so angle DAC is equal to angle BCA. Since AC is the transversal and alternate angles are equal, we can conclude that AD is parallel to BC. This implies that ABCD is a parallelogram. Let us do a small activity. Draw a triangle ABC. Mark midpoints E and F on the sides AB and AC of the triangle and join EF. Now, let us measure EF and BC. EF is equal to 3 centimeters. BC is equal to 6 centimeters. Now, using a protractor, we measure angle AEF and angle ABC. Angle AEF is equal to 60 degrees. Angle ABC is equal to 60 degrees. Let us now take another triangle PQR. We join the two midpoints O and M. Now, we measure OM and QR. OM is equal to 4 centimeters. QR is equal to 8 centimeters. Now, measure angles PQR and POM. Angle PQR is equal to 45 degrees. Angle POM is equal to 45 degrees. What can you conclude from this? We find that EF is half of BC and the angle AEF is equal to angle ABC. The same result is seen in triangle PQR also. This result is in fact a very important theorem called the midpoint theorem. The midpoint theorem states that in a triangle, the line segment joining the midpoints of any two sides is parallel to the third side and is half of it. Let us prove the midpoint theorem mathematically. Given in triangle ABC, BP is equal to PA, AQ is equal to QC. To prove, PQ is parallel to BC and PQ is half of BC. In triangle ABC, let us use a compass and scale to extend PQ such that PQ is equal to QR. Consider triangle AQP and CQR. PQ is equal to QR by construction. AQ is equal to QC is given. To prove that these triangles are congruent, what other property can we use? Yes, angle AQP is equal to angle CQR as they are vertically opposite angles. So, using SAS criterion of congruence, triangle AQP is congruent to triangle CQR. This implies that angle PAQ is equal to angle RCQ. And also, PA is equal to CR. But BP is equal to PA. So, this also implies that BP is equal to CR. Now, AP is parallel to RC. Why do you think AP is parallel to RC? This is because transversal AC intersects AP and RC and alternate angles are formed. Since BP is an extension of the straight line AP, we can also say that BP is parallel to CR. From this, what can we conclude about the quadrilateral PBCR? This means that PBCR is a parallelogram as a pair of opposite sides is parallel and equal. This implies that PR is equal to BC and PR is also parallel to BC as it is the other pair of sides for the parallelogram PBCR and should also be equal and parallel. Now, PQ is a part of PR, so this implies that PQ is parallel to BC. Since PQ is equal to QR, this implies that PQ is half of PR, which further implies that PQ is half of BC as PR is equal to BC.